Hi, we're going to talk about breaking out HSTS and HPKP on Firefox, Internet Explorer, Edge, and possibly Chrome. Thank you all for coming. I'm Sergio Santos. I'm Head of Innovation and Laboratory in 11 Path, which is Telefónica Digital Cybersecurity Unit. I come from Spain.
And I'm Sheila. Hi. I work as security researcher at 11 Paths as well. And I'm 22 years old, and I came from Argentina. Okay, let's start with a briefly introduction. We all know what happens when credentials are sent over the internet in clear text. Anyone in our LAN network can make a man-in-the-middle attack and to steal our credentials. That's why it was necessary to add a new layer of security. In order to provide it, SSL and TLS were created. So now, sensitive data should be sent over a secure communication channel. In the application layer, we can see it as HTTPS on the web browser. So, to steal our credential should not be so easy. But we said it should not be so easy, instead of it should be impossible, because there are well-known attacks against SSL and TLS. For example, Beats, Poodle, Crime, and Heartbeat. In fact, the whole ecosystem has proven to be, at least, not as strong as we thought. But in particular, there are two attacks more common than those mentioned before. The first one is HTTPS stripping, commonly implemented using SSL strip tool in a man-in-the-middle attack. In this scenario, the attacker gets in the middle of the client and server communication, redirecting all HTTP requests over HTTP. With this, the attacker can steal the user credential because he or she will send them over a non-encrypted channel.
The second common attack is the rogue certificates. You know how it works. Someone gets into a certificate authority network or plays the role of a certificate authority system, or gets some a problem in the procedures of issuing a certificate, and they get to issue a certificate that is not the real one. It's quite similar to the real one, but it's not the legitimate one. So all these both common attacks had a countermeasure, which is HSTS, HTTP Strict Sample Security, and HPKP, which is HTTP Public Key Pinning. There are others for certificate pinning. HPKP is one of them, not the most popular because, you know, Chrome is going to deprecate it, just announced it a few months ago. But it's a way of making the browser to remember that for HSTS that it has to be accessed always by SSL, and that the chain of trust has to be always the same for the browser. The first time the user visits the web page, and then the other time has to be the same. Basically, it's having the same three certificates or chain of trust.
Yeah. So let's start explaining how HSTS works. When we access a website for the first time and we try to do it over a non-secure connection, the web server will respond us with a 302 redirection to HTTPS. And that first unsecure connection is the one that SSL strip takes advantage of. From there, it will avoid the redirection to HTTPS, making the communication with the victim over a non-secure channel. But the question is, what happens if that first unsecure connection is not intercepted by an attacker? The second request will be sent over a secure channel by the user, and the HSTS header will be set on the user web browser. In the second screenshot, we can see the strict transport security header with the respective message. But what this means? It means that from now until the message expires, for that website, the web browser will resolve from itself every HTTP request over HTTPS, making no communication over a non-secure channel. So, though there is not a first unsecure request, SSL strip has nothing to intercept. so it won't work. The attacker won't be able to sniff the traffic and to steal our credential in clear text.
About HPKP certificate or certificate pinning, the whole idea is to remember the certificate chain. For example, if we go to GitHub, which is this example here, it will send us a header called public key pins, and in that header you will see a string, a pin SHA-256 string, which represents one of the certificates. And it just, at least the RFC commits you to have at least 2 pins. One of them has to be represent one of the certificates in the certificate chain, the trust, and the other one is a backup one that can be anything. It's supposed to be one certificate you're going to use in the future or one certificate you're going to use when there's some kind of problem. For example, this is spice or whatever. This hash, this string, is a base 64 encoding, basically the SHA-256 of the certificate. Not exactly like that. It's like the SPKY in the certificate, but basically is it. So you can send as many pins as you want, but at least there has to be one representing one in the certificate chain and one representing a backup that is not in the certificate chain of trust. If you visit that website again and the pins that you have sent to the browser are not anymore in that website, you will see a web page like this in Chrome. Have you ever seen this? Well, it says like network error SSL pins key not in the search chain. That means that these certificates that I'm getting right now in the network are not the ones you told me to remember. So I blocked the site because these strings have changed in some way. We're going to focus here, now we briefly know what HPKP and HSTS means. We're going to focus on how the browsers remember this information and store it. We're going to focus on Firefox, Chrome, and Internet Explorer. We have studied how they work, how they store this information, and we try to exploit it in some way.
Yeah. We begin talking about Firefox. Firefox introduced HSTS feature on version 4 and HPKP on version 32. This browser saves the data related to HSTS and HPKP in a text file named site-security-service-state.txt located in the Firefox user profile folder. If we open that text file with a text editor, we can see in the first time the domain along the type of header received. It can be HSTS or HPKP. And the important second column, there we can find the score. The score is a numeric value that is initialized as 0 the first time that the user visits a website. After, the score will be incrementing by 1 for each day that the user visits the website again. It takes as reference the current system date in contrast to the value stored in the third column. The value stored in the third column is the number of days from epoch when the user visits the website again.
In a nutshell, a score is the higher the score, the more often you visit the website in different days. And a score is a concept that belongs only to Firefox. It just has the way they have implemented it.
Exactly. So, another values that we can find in the text file is the max age, that this is the expiration time of the header. So, as we can observe, the text file is not friendly to analyze. That's why we made a simple plugin for Firefox named Pin Patrol, where we can see the sign information in a friendly way. We can see the domain, the type of header, the score value, the first access time, the expiration time, and if the domain uses HPKP, we can see the respective pins as well.
This plugin is in the official
store of
yeah,
Firefox.
You can download it. It's something we
free.
get for free. And it represents the score, as we said, and the higher the score, the more often you visit. And if the HST max age expires, it resets back to 0.
Exactly. So, what is the curious thing about Firefox? The very curious thing is that the maximum quantity of HSTS and HPKP entries that Firefox saves is 1024. It is explained in the Firefox source code. And it should be noted that a domain that uses both protocols will occupy 2 entries in the text file. So the question is, what happens if we try to fill up those 1024 entries with chunk entries? We will assume that the entries will begin to be overwritten. To test it, we made a simple JavaScript module that can be used together with Bettercap in a man-in-the-middle attack in order to remotely inject a lot of chunk HSTS entries to start to overwrite the decisive security service state file in the victim machine. This JavaScript module will generate a random subdomains with their respective HSTS header. We are owners of the cloudpinning.com website, and we have a SSL certificate for that domain. So each subdomain will occupy one slot into the site security service state file into the victim machine. As I said, we can use this JavaScript module together with Bettercap in a simple man-in-the-middle attack using the proxy module in Sheila.
We're going to see a video right now when we going to visit a website, and the attacker is, we want to check first that the browser actually remembers the domain, Instagram in this case, and then we want to give a rush of junk entries with our clouddomain.com own website. It can be anyone, it's public, but this is our own. And we're going to check later, we're going to give this rush of junk entries, and we're going to check that the attack has removed this domain, and then we're going to inject a Bettercap usual SSL strip attack. As you can see here, the maybe Netflix or Instagram are visited by SSL, and they are there in the implementation of Firefox in the way they store the HSTS entries with our plugin. Instagram is there, should be always be visited by HSTS. And now the attacker use Bettercap to inject this JavaScript that goes to cloudpinning.com and start like asking a lot of new domains to fill up these 1024 entries. And once the attack in the victim machine, the user goes to random place. Right now we use just holamundo.es or wherever. The attack starts sending junk entries. It takes about 2 minutes or maybe 5, depends on the speed you start in the JavaScript, the speed you start injecting junk entries. And once the injection takes place, he will go, the victim, well, we are going to check that the table, the 1024 table for Firefox, which is the maximum you can remember, is filled up with our own cloud pinning stuff, which is junk, and Instagram is gone. So it's that easy to make Firefox forget one of the HSTS entries that it used to remember. Now the attacker is going to make a SSL strip usual attack using Bettercap. It's a man in the middle. He has to be already in a hostile network, of course, but remember that this is just a previous attack. Removing HSTS is a previous attack for a real man-in-the-middle attack, so you're supposed to be in the network already. And when he visits Instagram, the SSL strip attack is taking place. Well, we got that before this alert came out in Firefox. So she's entering email and password, as you will guess. This password will be in the attacker machine just right there. as you can see. Email and passwords in clear text in the attacker machine.
Yeah. So, as we saw, lots of HSTS and HPKP entries has been overwritten. However, not all of them. Why? Because of the Firefox score. Inside the Firefox source code, we can find a comment that explains how the score system works. As we said before, the score is a numeric value that is initialized as 0 the first time that the user visits the website, and after will be incremented by 1 for each date that the user visits the website again. There is a limit of 1,024 entries, and when this limit is reached, those entries with the lowest score will be overwritten by the new entries. All of this means that it's most likely that with our previous attack, we are overwriting those entries corresponding to the website that are not the most frequently visited by the user, because we are injecting chunk entries with the score 0, and with this, we are overwriting another website with the score 0 as well, or 1 as maximum.
So in a nutshell, the lower the score, the more likely you're going to be evicted. So if we try to rise up our own score in our own junk entries, the more likely the good entries will be evicted from this 1024 table.
Exactly. So, what can we do? Some years ago was presented a tool named DeLorean that was developed by Jose Salvi. And this tool allows an attacker to change remotely the current system date of a target machine. It depends a little of the Linux or macOS version. Some Linux and some macOS version are more vulnerable. But this tool was developed for using against HSTS, trying to change the current system date of the target forward to the max age of the header of the HSTS headers. But even if we can do it, actually the web browser won't show any web page if the system time is exageratedly subsequent to the real time. So, however, we will use this tool in a different way in order to complement our previous attack. So, we'll begin making a first chunk HSTS entries injection, and with this, we will get a score of 0. After, we will use DeLorean to forward the target system date to 1 day on the future. After that, we can make another chunk entries injection, and with this, we will get a score of 1. And if we continue applying DeLorean together with the chunk entries injection, we can increment the score of our chunk entries. So with this, we can start to overwrite those entries corresponding to website frequently visited by the user. This means website with a higher score.
So in the next demo, we will make this attack trying to rise up the score of our own junk entries, so the good entries will have the lower score, or will be the score, and will be easier to be evicted or forgotten from your Firefox. Let's see the video. We here check that the victim is November the 9th, and we have already done the previous attack where our score is 0, and now the attacker is gonna run Berta for rushing the junk entries here, and DeLorean in the other command control. So with our JavaScript pointing to cloudpinning.com, we start the attack, and then we set DeLorean to make the user date jump 1 day before. Not a lot of days, but just 1 day. So next time you visit cloudpinning.com, it will be like score 1. So Ubuntu has asked for an NTP update, which is quite frequently. And then he is on November the 10th. He visits whatever web page the attack takes place, and the table will be now filled up with junk entries with a score of 1. And maybe we have already removed some good entries, some legitimate entries, with a score of 1. It's more likely. Then we're going to do it again. You stop the attack. We run again the DeLorean attack 2 days after our own system date. We run Berta to rush a lot of junk entries to the victim. Ubuntu has again asked for an NTP update, so the DeLorean attack takes place. Now he is on Saturday the 11th. The user again visits whatever web page, holamundo.es, for example. And if we check the table again, or our junk entries, we have a score of 2 right now. So we're more likely to remove entries with a 2 score, but because remember the policy is to evict the domains with the lowest score. So this attack may be a little complex because it depends on how many legitimate domains you already have, but it may be quite effective. DeLorean doesn't work with Windows, just works with Ubuntu. But it's a quite easy attack for man in the middle. And maybe we need some time enough inside the target networks, maybe hours, but for places where you're in a hotel and you visit a captive portal, or you're in an internal pen test, are the best scenario for this attack, because you have plenty of time to rise up your score a lot, and it will be, every single day will be more likely to remove your legitimate domains. And if you have more days, it's more likely as well that your max age expires. So it means your domains you're visiting expires and tries to get in, and they get a 0 score again, and they're easily evicted again from your table. So if you try this attack for maybe a day, maybe 2 days, maybe 3 days, the success arises because you don't choose which domains you're evicting, of course, but it's more likely that the lower the score, the easier they are evicted from this table. And with a higher score, we have more chances, with a higher score of our own domains, we have more chances to remove existing domains. But even if it doesn't work, it has a side effect, a very interesting side effect. When you have a lot of entries with a high score, they are less likely to be removed. So you're filling up this 1024 table with a lot of junk entries, and at the end of the day, the result, the side effect, is that you end up with just one entry that is going to have a score of 0, because the new ones, you have to remember them, and it has a 0 score. So if you have a lot of with a 2 score, 3 score, 20 score, whatever, at the end of the day, what you have is just one slot left to remember the HSTS or HPKP. And this is all the new entries that you're getting are removed by the new one all the time. So at the end of the day, in the long term, you defeat this system because you have just one single slot to remember. And the new ones you visit is going to overwrite that one, which is a quite interesting side effect attack. What about Chrome?
Nice effect.
Chrome follows basically the same policy as Firefox. It stores all this information in a TXT file in the user profile. It uses a JSON with lots of parameters, just basically the same. It doesn't have to do anything with the score anymore. Okay, it uses a JSON and the expiry time, the pins, and whatever. And this string here is the domain. For privacy purposes, the Chrome doesn't store the domains themselves. And the rest of the parameters are the same. We have created pin patrol for Chrome as well. is in the official store as well. So, and we got to unhash the domains because of a very easy technique. If you have visited them, these domains are in your history. So if you go to the history, this plugin goes to history, checks your history domains, hashes them, and if they match it, they are the same. So you unhash these domains in some way. And the curious thing about how Chrome storage uses this storage is that it has no limits at all. No limits the number of domains, and no limits in the number of pins. Firefox has a limit of 1 kilobyte of pins. That means about 21 pins, he can't remember. But Chrome has no limit at all. This means that you can set literally as many pins as the HTTP header allows you to. That means a lot. That means about thousands of pins. And it will remember whatever number of domains you have ever visited. It's a completely different philosophy from Firefox. So, what happens if we try to fill up the database with thousands and thousands of large junk entries? Large junk entries means domains that gives you back not 2 pins, not 3 pins, but thousands of pins. We made a proof of concept as well with this whatever free Wi-Fi portal or whatever. Then you enter this email, your domain, for example, click on connect, and you will see here we have made a simple system that sends this ping and another one, of course, because you need a valid one, remember, and the backup ones. By the way, we use this backup concept as a way to inject as many pins as we want, random pins. We send 4,000 pins for the domain, and we set it 50,000 times, all in a row, in a second, in a few seconds. So, in this demo, we're gonna see how this works. The user just clicks on this connect site, and we'll see in this debug frame that it's continually injecting these headers. If we could click on these headers, you will see like a massive HTTP header with thousands of pins. And it's taking, every time it's taking a little bit longer and longer and longer. And here you can see it's transferring a lot of megabytes. And this megabytes goes directly to this file, which is a TXT file, and dumps the information just right there. So the longer the transmission, just 20 megabytes right now, 30 megabytes transferred, are going to be translated into data into your file. Right now it's 40 megabytes, this is real time. And in a few seconds we'll get a massive TXT file or a massive system. In less than 10 minutes later, it depends on how many pins you send and how often you send them, we're going to have like 500 megabytes of information. That is a lot. We're not going to fill up the hard drive with this, but for Chrome, it's incredibly difficult to handle this file. As you can see, with just 500 megabytes, you cannot even type a domain anymore. It just freeze there. So this is real time as well. You cannot even type. So Chrome is useless right now because it's trying to read a massive file of 500 megabytes. Maybe in a more powerful computer it has to be a little bit bigger, but it doesn't matter. So the attack is very easy to achieve, and you can try in different ways. You just visit a website as long as it has a JavaScript. You may have this problem, whatever website. It doesn't have to be a man in the middle at all. Chrome stops working properly in a few minutes. And users is forced to clear browsing data in Chrome, but he will not be able to do it because you cannot even type. And transport security file has to be removed, deleted, or some way it is to start over again, so HSTS or HPKP is broken. or the user may switch to Firefox, where we can do the other attack as well. What about Internet Explorer or Edge? Well, as you can guess, there's no documentation about this. Internet Explorer doesn't even support HPKP, and it will not, because it's going to be deprecated. But it supports HSTS. We have not a real, we need a deeper investigation on this because it's quite complicated, but what we saw is that it uses what Microsoft calls ESE database, which is stencil storage system, I think. And we have used the closest thing to read this table we have found is a Nearsoft tool called ESE database view. But it doesn't parse the information the right way. So you get to see this information, but it's not properly seen. What we have in the second column are the domains, which are hashed. They are hashed in some way. We don't know how. And we see columns like last time used, which is updated, supposedly updated when Internet Explorer uses it for some reason. And as we said, there's absolutely no documentation about this. And we haven't seen it before on the internet or whatever. So what we try to do is, the funny thing about Internet Explorer is that it doesn't even seem to work. We make a simple test that is, we created 131 requests to our cloudpinning.com site that gives you an HSTS header or whatever. And we expected that this table was altered in some way. Because when you visit Google, you visit Microsoft, you visit popular Outlook, Facebook, popular domains, this database is altered in some way. You can check that last time used is the real last time you have used that. So this HSTS entry number, whatever in this table, is actually touched in some way by Internet Explorer when you visit a very popular domain. But when we visit our own domain, it's not even touched. There's nothing written in there. So it's not remembered at all. In what it's supposed it has to be. And what we observe is that even if you restart the Internet Explorer, restart the computer, it does remember nothing about visiting this website that is sending you a properly strict sample security header.
Yeah. In order to discover why Internet Explorer and Edge seems to not work well, we began to analyze the browser behavior in runtime when we access a website with HSTS. Like all above, there is not a useful documentation on that. The only thing mentioned is that there is an API called HTTP host HSTS enabled inside the WinNet library, and that's all. That was our starting point. However, along our research, we discovered lots of methods related to HSTS. And every time that a user visits a website, some of them are invoked. The first method invoked is check HSTS. After, get HSTS enabled. And depending on the result of this function, the rest of the methods might be invoked. So, the number of functions related to HSTS give the impression that Internet Explorer and Edge are ready to handle with HSTS. However, we found some issues. The functions that we can see there are frequently invoked by the web browser every time that the user visits a website. So in the sequence that we can see here, and there are more methods related to HSTS. But those methods related to the store of the HSTS entries are not invoked with the same frequency, or at least when we assume that they should be invoked. That's why we think that there is a kind of problem in the storage process. A conclusion we got is that there is the cache is the cache the one that remembers if the user visits the website over HTTP or HTTPS. But it's not because the HSTS protection itself. So the question is, what happens if we clear the cache?
In this video, we're going to show like we're visiting Google or Instagram, and they visit by SSL, which is okay. But when the user just removes cache or removes the data, and we get back to this HSTS database that is supposed to store all this information, the information is there. So this information they have remembered about Instagram or Google should be there. And next time you visit it, it should be accessed by SSL because of the HSTS itself. But just removing the cache in Internet Explorer, the attacker just sends some SSL strip usual attack. And when the user visits with Internet Explorer Google in this place, you will see that it's being attacked with SSL strip to, this is the typical attack, you go to www.google.com and HSTS is not taking place. And for Instagram, it's basically the same. Just removing the caches is just having or removing the effect of HSTS, even the table has not been removed at all, where it should be stored, but for some reason, when you remove the cache, the SSL strip attack is successful. And as you may guess, when you get your username and password in there, the attacker will be able to see it in clear text. And remember that the user did just remove the Internet Explorer cache.
So the highlights about Internet Explorer and Edge, we can say that most of the website won't be remembered as well protected with HSTS due to some kind of problem in the storage process. So we think that is the browser cache, the one that remembers if the user visits the website over HTTP or HTTPS, but it's not because of the HSTS protection itself. So as a consequence, restarting the browser, the machine, or more effective, clear the cache, leaves the user without a real HSTS protection.
So we need a deeper investigation on Internet Explorer just to reverse engineer it. But what we can tell is that there's not a strong bet yet for improving these implementations, because as you can see, Firefox uses a TXT file, Chrome as well as simple JSON file, and as a consequence, no one seems to be safe if even using HSTS. We have done a little more research about some problems in the way they implement this, and there are little details, but these are the bigger ones that actually is going to remove or make these mechanisms useless in a practical way for the most common browsers. Remember that the plugins are available, and the cloudpinning.com is available as well if you want to make some proofs with your own and have your own conclusions. So this is all. Thank you. I think we have time for some questions.
Maybe there's a question.
Is there a question there?
Oh, there is another one here. Yeah, tell me. Did you have a question? No. I don't know if there is a microphone. No, yeah, it's gone.
Someone raised their hand there. Here.
Thank you for a great talk. So you mentioned the tool DeLorean, and all of these fields seems to have expiries. What happens if you just set the time of the target to past the expiry? Would that work as well?
That's the DeLorean was meant to be, taking you 2 years forward in time, 2 years in the future. It is okay, it works. That's a way to defeat HSTS. That's one way to defeat it. But what we observe is that it has, this is another way, okay? But aside, just to say something, this has a big problem. That if you set your expire time 2 years in the future, and the user is right now 2 years in the future, it's quite likely that when you visit whatever domain, OSCP in your certificate just says, hey, this is not the real time, so this is not valid. So the browser is going to block you because of the OSCP. And there are going to be some problems with certificates as well. They may be expires as well. The certificate itself may expire if you set your computer to 2 years in the future. It has a lot of problems. But 1 day, 2 days is okay with OSCP, and certificate is not going to expire in 1, 2 days. So it's a little bit better way, or let's say less noisy way. But it's perfectly okay to get you back in the future until HSTS expires.
Okay, thank you.
Thanks for the great talk as well. I was just curious if you reported this behavior to Firefox or not, and what was the response if it was reported?
We did not. We did not because they're changing all the time. We haven't even had time to check for Quantum. Right now, I think it's exactly the same. We did not tell them about this because they know it. I mean, these comments that you're seeing in the source code, they explain this, but they don't seem to have any problem with it. They say it's okay in the proper comments in the source code.
Thank you for the great talk. Have you tried to investigate the mobile environment, meaning the Android or iOS?
We did there's a funny thing with Chrome. Chrome for Android works exactly the same. Just exactly the same. If you connect, you may see this TXT file with JSON. It's exactly the same. There's a funny thing that with Android 4, which is quite old, and Chrome, HSTS doesn't work at all. They say that it does, but it doesn't. It never uses this file. Don't ask me why. But it's just Android 4. For Firefox, it's the same as well. We did not check the native Android browser. We check Chrome and Firefox. If you ask me for Opera, for example, Opera is Chrome. It's basically exactly the same as well.
Did you check the web view-based applications such as the Facebook app itself?
The Facebook app? Sorry?
Yeah, for example, the Facebook app, which basically is just a web view. So internally, it uses the same implementation than the Chrome.
We didn't, but Opera is Chromium, and Chromium uses this part. This part is Chromium, not Chrome itself.
Hi, how would you fix this? Is there any good remediation for this?
I would say there's not a strong bet. I mean, I would have used a proper database. I would have checked limits, of course. I will not use that core system, which is an intelligent way of making you remember and store for longer the legitimate domains, but it has some flaws. I'm not a software engineer or architect, but I'm quite sure there are better ways. I mean, it's not just a single TXT file that you dump there, and it doesn't matter how how big it is, or just a simple table with 1024 entries that are going to be overridden in the long term. I'm not a proper developer, but I would use at least a single SQLite database or something, of course. But what I say is that it's not I don't know how to fix it, but as you can tell, it's not a proper bet. I mean, I'm going to do it the right way. It's like we're doing it and we forget about it and we'll check later. No questions? Okay. Yeah. Thank you very much.
Thank you.